And we're now recording. Set up the shared screen here. All right, so we're going on to new material, but anything that's new that I do this week and won't be covered on the test. So test is this coming Friday. It's our fourth exam. Coverage is just 4.1 to 4.8. I realize you only have an hour. So, it may take, we know that it takes some time to do a good curve sketch completely and some of the word problems. That's the reason why I gave you some on the quizzes where, you may not have enough time to do a whole good curve sketching problem on the exam, but I give it to you over the quiz, likewise for a word problem. They're still going to be there. There's still going to be curve sketching. There will definitely be curve sketching. There'll definitely be word problems on the test. I would just keep in mind that you only have an hour or technically 50 minutes to finish it. Okay, so I'll try to construct a test, keeping that in mind. And again, I'm going to keep going with a new material. Okay. Now, depending on how time goes, I may give you some time at the end of a particular class for questions and answers. I'm dedicating Thursday again for questions and answers. I may not be willing to do the whole thing, especially if it's a quote unquote long curve sketch. So I'll have to pick and choose what I'm willing to do in preparation for the test. But we're going to go on to 4.9 as according to schedule. Okay, if there's time at the end of today or any day this week, Monday, Tuesday, Wednesday, where I say, okay, I'll stop and let you ask questions, then we'll see if you want me to do any of the problems from here, then maybe I'll give you some time to do that. Okay. But for now, let's get back to 4.9, antiderivatives and so forth. Okay, so we did some last time and we're going to do many more. Okay, 4.9, problem 25 said f double prime is 20x cubed minus 12x squared plus 6x. Okay. So notice we're going backwards on what we've been doing all along. Okay. So you have to be careful. It's not asking what is the second derivative of this function, which you should all know how to do, right? If it asks for the second derivative, take the first derivative, take the second derivative. That's not what asking here. It's asking what functions are there back up here so that the second derivative of those functions comes out to be this. It's almost like going up and down an elevator. Okay, so I think of it as you're at this level, then it's like you take one derivative, then you go down one level, you take another derivative, you're down another level. Well, now we're down at the bottom level of the second derivative. How do I go back up to the first derivative? And then how do I go back up to the original function? Okay. So as you might guess, we had to take one derivative, second derivative. So for this one, we have to take one antiderivative and a second antiderivative. So we anti-differentiate, integrate twice. So f prime of x is the integral of 20x cubed minus 12x squared plus 6x dx. And even this might look weird because you look at it and say, hey, how can this be f prime? Usually f prime means I'm taking a derivative, I'm taking an antiderivative. Yeah, and that depends on what level you're at. So for the majority of the semester, you are always at this function way up at the top. And then you take a derivative, you're down at the derivative level, and you take another derivative, you're at the second derivative level. Okay, well now imagine going back up the elevator, you're at the second derivative level. You take one antiderivative, one integral, and yes, you are back at f prime, even though you didn't take a derivative, you took an antiderivative because you're going back up. Okay, and then you anti-differentiate one more time, and then you get back up at the f level. All right, so I use the power rule. What's the power rule? Keep the coefficient the same, add 1 to the new exponent, and then divide by the new exponent, right? So 20 x to the fourth over 4 minus 12 x cubed over 3 plus 6x squared over 2 plus C1. I showed you before plus C. Now there's going to be more than one constant because we have to integrate, anti-differentiate twice. So there needs to be a C1 and a C2. So you can't just say C for both of them because if you do, that implies that those C's have to be the same, and they definitely do not have to be the same. So we're going to use C1 and C2. And of course, this simplifies to 5x to the fourth minus 4x cubed plus 3x squared plus C1, which you can always double check. How do I double check this is correct? Take the derivative. What's the derivative of that? 20x cubed. What's the derivative of that? Minus 12x squared. What's the derivative of that? 6x What's the derivative of any constant? 0. So it works. All right, so I've gone up the elevator, so to speak. I was at the second derivative level. I'm now at the f prime level. So I anti-differentiate, integrate one more time, and then I'm back at the f level. So I integrate this thing. 5x to the fourth minus 4x cubed plus 3x squared plus c1. I integrate that dx. Integrate with respect to x. Okay, so one more time. Power rule again. 5x to the fifth over 5 minus 4x to the fourth over 4. Remember the power rule, right? Leave the coefficient alone. Add 1 to the exponent and divide by the new exponent. Plus 3x cubed over c. How do you integrate c1? Remember, c1's a constant. Just pretend it's 7 or negative 5. So what's the integral of 7? 7x. What's the integral of negative 5? Negative 5x. So what's the integral of c1? C1x plus another constant, which we will say is C2. Okay. And then, of course, notice what happens when you clean this up. Very nice. 5's gone, 4's gone, 3's gone. So final answer, x to the fifth minus x to the fourth minus plus x cubed plus C1x plus C2. Okay. And now you can see why I put C1 and C2. That means C1 and C2 are allowed to be different. They don't have to be different, but they could be different. So technically, it's not correct to put plus CX plus C. That would imply these two C's have to be the same, but they certainly don't. That can be 7. This can be 24 or whatever. Okay, so this is the answer. What does this answer represent? It represents a whole class of functions, infinitely many functions. Just give me a different number for C1 and C2. The second derivative of any of these infinitely many functions comes out to be this. Okay, I won't take the time to do it, but you can double check. Okay, take the second derivative of anything that looks like this, and you should get this. And it should be obvious that these drop into nothing, right? If you take the first derivative, that's gone, right? If you take the first derivative of C1x, you get C1. So by the time you get to the second derivative, it's gone. So the only thing that's left of any substance are these three guys. Okay, and if you take the second derivative of these, you should end up with that. Okay. All right, so that's that. 29, f triple prime of 12 plus sine t. So we're at the third derivative level. So it's 3 levels down. Imagine you have a function, right? Then you take first derivative, second derivative, third derivative. Now you're going back up. I'm at the third derivative. So I integrate, second derivative. Integrate again, first derivative. Integrate again. I'm back at the original function's height, so to speak. Okay. So we're not asking for the third derivative of 12 plus sine t. We're asking what functions are there whose third derivative ends up being 12 plus sine t. Okay, and before I do that, just think about here. I need a C1, C2, right? Can you guess how many C's I need over here? I'm going to need a C1, C2, and C3, right? You integrate once, C1. Integrate again, C2. Integrate again, C3. So in general, you need as many C's as the levels of integration that you're going back up. Okay. So here's f triple prime. F double prime is the integral. And I know that sounds weird. You say, hey, how can this be the second derivative? I didn't take any 2 derivatives. I just took one antiderivative. Yeah, it's because of where we're starting. We're starting down at the third derivative level, right? Way down here. So I press the button for the elevator, right? I go up 1 level. Now I'm at the second derivative. Not that I took 2 derivatives, because all throughout the course, we always started at this top level, and we were always taking 1 derivative, okay, then down at the first derivative level, and do again second derivative. We didn't do a whole lot of third derivatives, but you can do as many derivatives as you want. Okay, we're starting at the third derivative level. So I integrate once, I'm at the second derivative level. Okay, so integral of 12 dt, the variable is t. Okay, if it said dx, then I would put 12x. But since it's dt, 12t minus cosine of t plus c1. And again, how can I check my answer? Take the derivative. What's the derivative of this? What's the derivative of 12t? 12. What's the derivative of negative cosine? The derivative of negative cosine is negative sine or positive sine. And the derivative of c1 is, of course, 0. So I know this works. All right, so I'm at the second derivative level. Integrate one more time. I'm at the first derivative level. So integral 12t minus cosine t plus c1 dt. So integral of 12t, remember that's like t to the 1. So 12t squared over 2. Integral of negative cosine t is negative sine t plus c1t. What's the integral of a constant? It's the constant times the variable that you're doing, so c1t, plus another constant, c2. And of course, clean this up to 6t squared minus sine t plus c1t plus c2. Again, double check. Is the derivative of this? So what's the derivative of 6t squared? 12t. Derivative of negative sine, negative cosine. Derivative of c1t is c1, and the derivative of c2 is 0. So it definitely works. And one more time, and I finally get f of t. So integral of 6t squared minus sine of t plus c1t plus c2. So power rule, 6t cubed over 3. Careful here. Integral of negative sine is positive cosine because derivative of cosine is negative sine. Integral of c1t, c1t squared over 2. Integral of c2, it's a constant, c2t, plus another constant, which could be different than this one and this one, so plus c3. And a little bit touch up. 6 divided by 3 is 2, 2t cubed plus cosine t plus 1/2 c1t squared plus c2t plus c3. Okay. Now here's a technicality. That's sort of correct, but the cleanest way to do it is to write it like this. And what did I do? I left that alone, left that alone, left that alone, left that alone. Okay. How did I go from here to here? Basically, C1 can be any real number. If I take any real number times 1/2, I still run through all the real numbers, which means I'm allowed to just leave it as C1. C1t squared plus C2t plus C3. I get every real number by putting C1. If I put in any real number for C1, 1/2 C1, I get all the real numbers also. So the best way to write the final answer is 2t cubed plus cosine t plus c1t squared plus c2t plus c3. Okay, I know that's a little bit different, weirder concept, but c1's an arbitrary constant. It'll get you all the real numbers when I multiply by 1/2. So if that can happen, you might as well just leave it as c1t squared. Okay, and if you're not convinced of that, go ahead and take the third derivative of this. The third derivative of this will come out to be that. Okay, in fact, that's not that hard to check. Okay, what's the derivative of this? 6t squared, whose derivative is 12t, whose derivative is 12. Works. Derivative cosine, negative sine, take another derivative, negative cosine, take another derivative, sine. And you know the third derivative of this, this, and this are all going to be 0, right? First derivative, 2c1t. Second derivative, 2c1, constant. So third derivative is gone. Likewise, these are going to be gone. First derivative is c2, so second derivative is gone, third derivative is gone. First derivative of this is 0, second derivative is 0, third derivative is 0. So it definitely works. It works. Okay, so that's the way these work. Okay, now, once again, for more problems where we can find what the C is, so 41, f double prime of theta is sine theta plus cosine theta, but they now say f of 0 is 3, f prime of 0 is 4. Okay, so something like 41. Once they give you that extra stuff, like 41, f of 0 equals 3, f prime of 0 is 4, your final answer should not have any C's. You're going to be able to solve for C. Okay, and I'll show you how to do that. Now, these problems didn't give me any extra stuff. So my final answer will have a C1, C2, C3, or whatever. Okay. Once they give me this, I know my final answer doesn't have to have any C's. All right, so here's the second derivative. So what's the first derivative? It's the integral of sine theta plus cosine theta d theta. Okay, again, it's weird because we're used to all semester saying, oh, f prime of theta, I must be differentiating. Here, you're not differentiating, you're anti-differentiating because you're down at the second derivative level. So how do I get back up to the first derivative level? I have to integrate. So integral of sine theta plus cosine theta d theta. Integral of sine, careful, not the derivative of sine. Integral of sine, it's negative cosine theta. What's the integral of the cosine? Again, careful, not the derivative of the cosine. Integral of the cosine is the sine of theta plus C1. Again, how can I check my answer? Take the derivative of this. Derivative of negative cosine is positive sine. Derivative of sine is cosine. Derivative of any constant is 0. So I know that works. Now, they tell me f prime of 0 is 4. I'm at the f prime level. That means when I plug in 0, the answer is going to be 4. So what I do is put a 0 there, put a 0 there, and a 4 here. That allows me to solve for C1. That means 4 equals negative cosine of 0 plus sine of 0 plus C1. Okay, from trig, cosine of 0 is 1, so that's negative 1. Sine of 0, that's a 0 here, sorry. Sine of 0 is 0 plus C1. Add 1, C1 is 5. Okay, so now that tells me instead of writing this for f prime, I can get better since I know C1 is 5. So f prime is now negative cosine theta plus sine theta plus 5. Okay, so what does this one function, it's not infinitely many functions now, one and only one function has two properties. Property number one, its derivative should be this thing. Let's check. What's the derivative of negative cosine? Positive sine. What's the derivative of sine? Cosine. What's the derivative of 5? 0. It works. Property number two, for the derivative function, when I plug in 0, I should get 4. So plug in 0. Negative cosine of 0, that's negative 1, plus sine of 0, 0, plus 5. Negative 1 plus 5 is 4. It works. So I know I did it right. Okay, so this is f prime. Integrate one more time to get back the original f. So again, sort of like all semester long, we've been going down the elevator, so to speak, and now we're going back up. We are at this so many derivative levels, right? So integrate to go back up the elevator, go back up to the first derivative, and go back up to the original function, so to speak. Okay, let's see, where was I? So now to find the original function, I integrate that. So integral of negative cosine theta plus sine theta plus 5 d theta. All right, so here we go. Integral of negative cosine is negative sine. Integral of sine is negative cosine because the derivative of negative cosine theta is the sine. Integral of 5 d theta is 5 theta. Again, this names the variable. If this said x, I would put 5x. If it said t, I'd put 5t, right? This names the variable. And then plus another constant, which I'm going to call C2. Again, double check at this stage of the game. What's the derivative of negative sine? Negative cosine. What's the derivative of negative cosine? Positive sine. What's the derivative of 5 theta? With respect to theta, it's 5. And the derivative of C2 is 0. So it definitely works. Now I use this other piece of information. F of 0 equals 3. So when I'm at the F level, when the elevator is up here at the original function level, when I plug in 0, I get 3. Okay, so plug in 0 here, 0 here, 0 here, and the answer should come out to be 3. So 3 is by itself. Negative sine 0 minus cosine 0 plus 5 times 0 plus C2. Okay. Sine of 0 is 0, so negative 0 is still 0. Cosine of 0, that's 1, so that's negative 1. 5 times 0 is 0, C2. Add 1 to both sides, C2 is 4. Put a 4 back here, and now I have my final answer. So it's not a whole bunch of functions. It's one and only one function. That one function is negative sine theta minus cosine theta plus 5 theta plus 4. Okay. And a double check. F of 0 is 3. At this level, when I plug in 0, I should get 3. So put a 0 there, that's gone. Put a 0 there, that's gone. Put a 0 there, I got negative cosine of 0, which is 1. Negative 1 plus 4 is indeed 3. So I don't have a plus C or C1, C2, whatever. There's only one function which satisfies 3 requirements. The 3 requirements being second derivative is that. Okay. Plug in 0, you get 3. Plug in 0 to the first derivative, and we already checked that, right? When I got to the first derivative level, when I plug in 0, I'm supposed to get 4. Okay, so all of that comes into play. Okay. Okay, next one I'm going to show you is 47. It's a little bit unusual, but nothing that you shouldn't be able to figure out. F double prime is x at negative 2. X is greater than 0. So they give me that extra thing there, 47 there. X is greater than 0. And then f of 1 is 0, f of 2 is 0. Okay, so it's a little bit unusual. Something a little bit different about that one. And we'll see why. Okay. So this is the second derivative level. So get to f prime, I integrate. So what's the integral of x at negative 2? Power root, add 1, divide by the new exponent. So x at negative 1 over negative 1 plus c1. That's negative 1 over x plus c1. However, I can't plug in anything right now because both of the things that I have here for information is at the f level. It doesn't say f prime of blah, blah, blah. I'm at the f prime level, so I can't do anything. Now, this is different than what happened over here. Because for this problem, they gave me some information at the f prime level, and they gave me some information at the f level. Here, both pieces of information are at the f level. So I'm at the f prime level. I don't know anything, so I'm stuck. I just have to go with it. Okay, so just leave it as this for now. Integrate again. I messed up here. That should say f of x. I think I put a prime at first. Okay, so f of x is the integral of this, negative 1 over x plus c1. All right, so the integral of negative 1 over x is negative ln absolute value of x. Okay, so at least at the beginning, I start off with this. Okay, the integral of 1 over x, remember, is ln absolute value of x. And what's the integral of c1? c1x plus c2, another constant. However, they told us that x is greater than 0 in the original part of the problem. If x is greater than 0, I can drop the bars. So that's the reason why they put that. Okay, so again, in general, the integral of 1 over x is ln absolute value of x. But since they said x is greater than 0, then it doesn't matter if you have the bars, just drop it. So negative ln x plus c1x plus c2. Okay, and that's because x is greater than 0. Now, I have 2 pieces of information at the f level. F of 1 is 0, f of 2 is 0. I plug them in, I'm going to get a system of equations, 2 equations, 2 unknowns. Okay, so that means when I plug in 1, where'd it go? Plug in 1, I get 0. Okay, so plug in 1, negative ln 1, plug in 1 plus c1 plus c2. Okay, now natural log of 1 is 0. So 0 equals c1 plus c2. Subtract c2 on both sides. c1 equals the negative of c2. c1 and c2 are opposites. All right, now keep going. Use the other piece of information. which is not going to be as nice. F of 2 equals 0. So plug in 2 here and here, and the answer is also 0. And this is what it looks like. 0 equals negative ln2 plus 2c1 plus c2. I plugged in for x here and here. Add ln2 to both sides. ln2 equals 2c1 plus c2. Again, that 2 and that 2 come from over here. Put a 2 there and a 2 there. I also had 0 equals c1 plus c2 way down here. And now, you might recall we have a system of equations, 2 equations and 2 unknowns that you can solve from algebra, right? Okay, so what I decided to do is multiply top and bottom by negative, on this side I multiplied both sides by -1, and then I'll add, right, by substitution. So natural log of 2 equals 2c1 plus c2. Multiply the second equation by -1. -1 times 0 is 0. -1 times this would be negative c1 minus c2. And then I add them up, right? Remember doing that in algebra? So add these up. This drops out. C1 is natural log of 2. And since C1 and C2 are opposites, if this is natural log of 2, C2 is negative natural log of 2. And there we go. So that's going to be my C1. That's going to be my C2. Put them back here and here. And finally, I have my answer. And here's that answer. F of x equals negative natural log of x plus x ln2 minus ln2. That's C1, that's C2. So that's it. And a quick word, the coefficient here, so what's the coefficient of x right here? It's natural log of 2. But this is preferred over writing ln2x. Okay. But if I write ln2x, that might be very ambiguous. In fact, the normal way to interpret this is the natural log of 2x. Most people don't think of it as this, right? I want the natural log of 2, 0.693 times the x. So to avoid that, put the x in front. Okay. See, now when you write it like this, nobody's going to think of it as ln of 2x. Okay. But we're still going to use the word coefficient. Okay. Normally, when you say coefficient, it's the number in front. Okay. So the coefficient of x here is natural log of 2. It's like saying 0.693x, something like that. Okay, so that's my answer. Properties of this answer. Second derivative is that. Okay, you can check if you wish. Okay, well, the second derivative of that is clearly 0, and that's clearly 0. That's a constant, so its first derivative is 0, therefore its second derivative is 0. The derivative is 0 is 0. The first derivative of this is ln2, a constant, so the second derivative is 0. So the only thing you have to think about is that one. Okay. All right, so that's that. I'm almost done with the section. The only thing I have left are the problems at the end, 59 through 63. And then I'm just going to mark this off that I'll be done. So that's 3 problems. I'll show you how to do one of them. Okay. But it's almost just like what we've been doing. All right, I see S, V, and A. Okay, distance, velocity, acceleration. So we've already seen this before, right? If you have a distance function, S, the first derivative is velocity, the second derivative is acceleration. Okay. But look over here. If you start off with velocity, how do you get back up to distance? Anti-differentiate, integrate, right? Before it was always, here's the distance function. How do I find the velocity? Take the derivative. Well, this is backwards. I'm starting at the velocity level. How do I get back to distance function? Integrate, anti-differentiate. A little bit harder. They give me the acceleration function. So the first integral, opposite of first derivative, will get me to the v level velocity. Do it one more time. I'm at the original, right, distance. So I'll just show you how to do one of these, and maybe that's about it. Okay, I'll do 63 because it looked the hardest. Acceleration is blah, 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 and give you all this information. Okay. So 63. So notice this is backwards from what we did before, right? So again, S is for a distance function. Okay, we've written that before, so I don't think I need to write it again. V is velocity, A is acceleration. So what did we say? If you have a distance function, first derivative, come down one level, velocity. Do it again, acceleration. Now this is backwards. I'm starting acceleration. So I integrate, anti-differentiate. I'm back up to the velocity level. Anti-differentiate, integrate one more time, and I go back up to the distance function, right? So it's just a matter of whether am I going down or up the elevator. Okay, so this is the second derivative level, right? A of t. This is just like, you know, the previous problem where it says f double prime. I am at the second derivative level. How do I go back to the original? And these two pieces of data are at the S level again. Okay, so how do I get the velocity? Integral of 10 sine t plus 3 cosine t dt. Okay. I know that's weird because you say, I always thought velocity was the first derivative. That's right, because before we always started at the S level, the distance level. Okay, so it depends on where you're starting from. I'm starting way down at level 2 of the acceleration. So when I anti-differentiate, I'm now at the velocity level. I did not take a derivative, I took an anti-derivative, right? All right, integral of 10 sine t, negative 10 cosine t. Integral of 3 cosine t, 3 sine t, plus C1, right? Remember, double check. What is the derivative of this, right? The derivative of negative 10 sine t is negative 10 cosine t. Oops, where am I? Sorry, I'm supposed to be over here. Got ahead of myself. Yeah, integration, yeah. Derivative of negative 10 cosine t is 10 sine t, right? Derivative of 3 sine t is 3 cosine t. Derivative of C1 is 0. Okay, so we're good. So finally get back to the S level. I integrate this. Integral of negative 10 cosine t plus 3 sine t plus C1. So integral of negative 10 cosine t, negative 10 sine t. Integral of 3 sine t, negative 3 cosine t. Integral of C1, C1t, plus another constant, C2. Again, double check going from here to here, take the derivative, right? We're doing anti-differentiation, okay? Again, setting you up for Calc 2, when you get to Calc 2, a major topic is anti-differentiation, integration, okay? It's usually harder to go the integration level than the differentiation level. So if I did this correctly, then the derivative of this should be this. Let's try it. What's the derivative of negative 10 sine t? Negative 10 cosine t. What's the derivative of negative 3 cosine t? Positive 3 sine t. What's the derivative of C1t? C1 is any constant. 3, 10, a million, negative 316,521.414828. They're all allowed. The derivative would just be C1. Plus C2. What's the derivative of C2? Any C2? 0. So it works. Okay, how do I find C1 and C2? I now use this information right over here, right? To tell me S of 0 is 0. and s of 2 pi equals 12. All right, so I plug in 0, I get 0. So 0 is the answer when I put a 0 there, and a 0 there, and a 0 there. So 0 equals negative 10 sine of 0 minus 3 cosine 0 plus 3 C1 times 0 plus C2. Okay, so 0. Sine of 0 is 0, so multiply by negative 10, that's 0. Cosine of 0 is 1, so that times negative 3 is negative 3. C1 times 0 is 0 plus C2. Add 3 to both sides. C2 is equal to 3. So one more time, S of 0 equals 0 means plug in 0 for t, and the answer comes out to be 0. So C2 is 3. So put that 3 back in there. So my S of t is copy that, copy that, copy that, but change that to 3. Negative 10 sine t, same as that. Negative 3 cosine t, same as that. C1t, same as that, but C2 change to 3. Okay, and now how do I find C1? I plug in 2 pi, and the answer is supposed to be 12, right? Just said S of 2 pi equals 12. So put a 2 pi here, here, and here, and the answer comes out to be 12. So negative 10 sine 2 pi minus 3 cosine 2 pi plus C1 times 2 pi plus 3. Okay, sine of 2 pi is 0. 0 times negative 10 is 0. That's okay. Cosine of 2 pi, go around a unit circle once. That's 1. So 1 times negative 3 is negative 3. And 2 pi times C1 plus 3. Okay, very nicely. That 3 cancels that 3. So I have 12 equals 2 pi C1. Divide both sides by 2 pi. So C1 is 6 over pi. So my answer is just 6 over pi. All right, plug that back in, and I'm done. So C1 right here, plug in 6 over pi. There's my answer. Negative 10 sine t minus 3 cosine t plus 6 over pi t plus 3. And we are finished. Okay, so I am now officially done with 4.9. Again, 4.9 will not be on this Friday's test. Okay, I'm ready to start 5.1. I won't do much today except show you, what's it about, give you introduction to it. Okay, so 4.9, I'm actually a day ahead, so that's okay. I guess I'll start, call this as 5.1 for tomorrow. Okay, let me do my focusing thing. Okay, let me double check where I was. So just a moment to do the focus job. That, then the middle column. And the last column. And there's all that. Okay. Okay, so in the last few minutes, I'll just give you an introduction to 5.1. And whatever I do today will just help me for next time. Okay, and the author starts us off as integrals, and we already started that a little bit. Okay, so I'm going to go to 5.1, and when I do 5.1 and 5.2, perhaps you're going to look at it and say, this seems to have absolutely no relation to 4.9, but it does. So hang in there. We're going to tie it all together. But it seems like we're shifting gears and doing something completely different. Okay, so what's happening here? Page 366, areas and distances. Here's the concept we're going to look at now. Here's some function, y equals f of x in blue here, going from x equals a, x equals b. Okay. I'm going to assume that it's a positive function for now, but it doesn't have to be. What I'm trying to do is address the question of how do I find the area under the curve here, right? So under the curve, y equals f of x from x equals a to x equals b. Okay, you're saying, well, I don't know how I can find this, right? unless it's a very special shape, like a rectangle or a triangle. I know how to do those, but how about if it looks like this? I can't do it in general. Okay. So what do I do? First thing we can do as a try, which actually doesn't answer the question, but figure 3, page 366. Y equals x squared between 0 and 1, right? I'm trying to find the area under that curve. Because it's a curve, right now it seems like, hey, I don't know what to do. I'm stuck. How do I figure it out, right? Right, so here's our first guess as to what to do. Figure 4. What did they do? They partition interval from 0 to 1, chop it up into 4 equal pieces. Okay, so how'd they get 4? They just made it up. Okay, so I break it up into 4 equal subintervals: 1/4, 1/2, 3/4, and 1. And there's a better focus, but the book is too heavy, so I have to put it right back down. And they call it regions S1, S2, S3, S4. Okay, so if I can find S1 plus S2 plus S3 plus S4, it'll be the same as what they call S, right? It seems to beg the question, saying, well, what good is that? I can't do S1, S2, S3, S4 either. And that's true. However, I can do this. Suppose I went like this. Go from 0 to 1/4. I'm going to go up until I touch the curve and then draw myself a rectangle. And same thing for S2. From 1/4 to 1/2, go up till I touch the curve, draw a rectangle. Same thing here, same thing there. So in other words, in each case, I'm taking the right endpoint, the point at the furthest to the right, go straight up, draw a rectangle. Okay, I can compute these 4 areas. Right now, see, that's cheating. That's not going to give me the true area. I've got clearly too much. I'm trying to find the area under the curve. I've got too much because I got this extra space here and this extra space here and this extra space here and this extra space here. And you'd be right. The answer is too much. It's an overestimate. Okay. However, I know how to do this because I know how to find areas of rectangles, base times height. So in this case, I can find an overestimate. I can do base times height, base times height, base times height, base times height, add them up. It won't be the area. We know that. We do know it's above. It's going to be more than a true area because I'm not supposed to have that, right? And I'm not supposed to have that. I'm not supposed to have that. I'm only supposed to have the area underneath the curve. Okay. Now, figure 5. What's happening here? I've got some rectangles which seems to be too small. Back to this picture. Take the left endpoint on each subinterval from 0 to 1/4, 1/4 to 1/2, 1/2 to 3/4, 3/4 to 1. Take the left endpoint. In this case, it'd be 0. Go straight up until you touch the graph and draw a rectangle. Well, if you're at 0, going straight up means you don't do anything. That's why I don't see any rectangle there. Well, you can say the first rectangle has a height of 0, which means nothing there. Okay, but you can see from 1/4 to 1/2, I could do that. Take the left endpoint, 1/4, go straight up, draw a rectangle. Now it's clearly too small. Likewise, for the third subinterval, from 1/2 to 3/4, I'll go straight up till I touch the graph, draw a rectangle. That's that one, too small. And the last subinterval, going from 3/4 to 1, go straight up till I touch the curve, draw a rectangle. I get this. Why do I make rectangles? I know how to find areas of rectangles, base times height. This will be an underestimate because look, the white space, right? The white space is what I'm losing in area. I lost that area, I lost that area, I lost that area, I lost that area. Okay. However, I can use that and say, okay, I now have an underestimate. Now, They took the sum of these rectangles as an overestimate. You could do that. I'll show you how to do that eventually. 0.46875. How to get that? They literally did base times height, base times height, base times height, base times height. Okay. So the true area is less than 0.46875 based on that picture. This picture, base times height, base times height, base times height, base times height. Notice the first base times height is 0. The height is 0. And then they did base times height, base times height, base times height, 0.21875. It's too small. The true area is between those two numbers, 0.21875 and 0.46875. 0.21875 is the sum of the areas of those rectangles. 0.46875 is the sum of those rectangles. So we've trapped, right? We've trapped the true area between these two numbers. Okay, and I see we're just about out of time, so I'll stop here. Tomorrow I'll keep going with 5.1. And so schedule-wise, I'm going on to this material. It will not be on Friday's test. Again, Thursday, I'll dedicate the entire time for questions and answers. If you have questions and answers on Thursday, and then Friday's the test. All right. Okay, so that's about it for today, folks. And let's see, if you came a little bit late, go ahead and put yourself in the chat. Let me answer some other questions. Attendance. So yes, homework, you're only turning in 4.1 to 4.8. You are not turning in 4.9. Okay, not necessary. And yeah, I think everything else is good. We're up to date. Okay, so that's about it for today, folks. So everybody have a good day, and we'll see you tomorrow. Okay, bye, everybody. Bye.